Welcome to our channel. Today, we're venturing on an exploration into a realm that's both unusual and riveting, where the typical villains of our everyday world, the viruses, take on the heroic mantle, fighting the most formidable microbial enemies. We are about to unravel the saga of the Bacteriophages, a term derived from bacteria and the Greek phagein, meaning to devour. These are entities that aren't just intriguing but also hold a promise for our future health. Bacteriophages, or simply phages, are a kind of virus that infect and kill bacteria. In this fascinating world, they are the knights in shining, combating the dark forces of bacterial infections. They are nature's own elegant solution to fight the bacteria that threaten our well-being. Their significance becomes even more potent as we grapple with the mounting menace of antibiotic resistance. Our journey today will take us through the intricacies of their life cycle, their unique ability to adapt, and how scientists are harnessing their power for medical breakthroughs. This is no ordinary tale. It's a story of resilience, adaptation, and a battle for survival that's been unfolding for billions of years. So, buckle up as we navigate through the labyrinth of this microbial warfare. We'll delve into how these pint-sized, yet powerful warriors just might hold the key to unlocking a future where we can effectively combat resistant bacteria. Stay tuned as we explore how these tiny warriors might be our best hope against the growing threat of antibiotic resistance. Bacteriophages, also known as phages, are a type of virus that specifically target bacteria. These are not the type of harmful viruses that you may commonly associate with human diseases and illnesses. On the contrary, phages serve unique purpose in the world of microbiology. They carry out a specialized mission, a quest you could say, which is to locate and obliterate bacteria. This intriguing process commences with the phage identifying and fastening itself onto the bacterial cell. Once securely attached, the phage injects its DNA into the bacterial cell. This is where the real magic happens. The phage's DNA takes over the bacterial cell's machinery, transforming it into a phage production factory. The bacterial cell, now enslaved, begins to create more and more copies of the phage, overworking itself in the process. As the bacterial cell is filled to capacity with the newly created phages, it eventually bursts. They do this by attaching to the bacterial cell, injecting their DNA, and taking over the cell's machinery to produce more phages, eventually causing the bacteria to burst. For decades, antibiotics have been our go-to weapons against bacterial infections. These little miracles of science, known as antibiotics, have been a trusty ally since their discovery in the 1920s. They're like magic potions that have successfully combated numerous bacterial infections, saving millions of lives and preventing countless complications. However, like in most epic tales, our hero has a flaw. This flaw lies in our over-reliance and mismanagement of these potent drugs. Over time, as we have heedlessly prescribed and consumed antibiotics, we've paved the way for a dangerous consequence: antibiotic resistance. Phenomenon is no less than a horror movie in the making. It means that bacteria, the very organisms antibiotics were designed to kill, are rapidly evolving. They're adapting, surviving, and growing stronger against the very weapons meant to eliminate them. This evolution results in the emergence of superbugs that are impervious to known drugs and make some infections extremely difficult to treat. Enter bacteriophages, a potential game-changer in this fight against harmful bacteria. These tiny warriors, also known as phages, are being hailed as the new vanguard in the battle against bacterial infections. Unlike antibiotics, which tend to be indiscriminate, wiping out both harmful and beneficial bacteria alike, phages operate with surgical precision. They are incredibly specific in their operations, targeting only certain types of bacteria. Research has shown that each phage has its own unique range of bacteria it can target, making them a personalized weapon in this crusade. This highly specialized approach means they can launch focused attacks on harmful bacteria while leaving the beneficial ones in our body completely undisturbed. In addition, phages have an added advantage over antibiotics. They evolve along with bacteria, which makes it much harder for these microorganisms to develop resistance against them. The adaptive nature of phages, their ability to mutate and evolve, keeps them always one step ahead in this microbial arms race. Plus, it's much harder for bacteria to develop resistance against phages due to their adaptive nature. Research supports the promise of phages. This fascinating area of study has captivated the attention of scientists worldwide. They have that phages, which are viruses that infect bacteria, have the potential to revolutionize modern medicine. A significant amount of research has been dedicated to understanding how phages work and how they can be used effectively to combat bacterial infections. A wide array of studies indicates that phage therapy can provide a viable solution for combating drug-resistant infections. There have been multiple instances where patients who were rendered helpless by deadly bacterial attacks and where antibiotics had failed were ultimately saved by the application of phage therapy. The scientific community is not just stopping at that. They are currently pushing the boundaries of phage therapy by exploring phage cocktails. The idea is to combine different phages to target a more extensive range of bacteria, thereby increasing the effectiveness of this treatment. Scientists are also exploring phage cocktails, combining different phages to target a broader range of bacteria. Despite their potential, phage therapy faces hurdles. Phages are naturally occurring viruses that have the potential to effectively combat bacterial infections, providing a promising alternative to traditional antibiotics. But the path to widespread adoption and usage is fraught with obstacles. The first hurdle is regulatory approval. It is critically important for the medical community to have complete assurance that phage therapy is safe and effective. And getting that assurance requires a rigorous and time-consuming process of clinical trials. Another major challenge is large-scale production. Scaling up the production of phages to a level that can meet global demand is a complex process with many technical difficulties. Finally, there's the challenge of ensuring safety. Given that phages are viruses, it is paramount to ensure that they are used safely and do not cause unintended harm. However, despite these challenges, ongoing research and technological advances are paving the way for phages to become a vital part of our medical arsenal. The journey of bacteriophages from discovery to a potential solution against antibiotic resistance is a testament to nature's ingenuity. These bacteriophages, or phages for short, are viruses that can infect bacteria, replicating within them and often leading to their destruction. Their discovery was a monumental leap in the scientific community, and their potential is still in its infancy of being understood. As we delve deeper into the microscopic realm, we too understand the complex and nuanced relationships that these phages have with their bacterial hosts. Their potential to combat antibiotic resistance is a frontier that has the scientific and medical communities intrigued. Phages might hold the key to surmounting one of the most significant challenges that modern medicine faces today. As we continue to explore and understand these microscopic warriors, we may just find the answer to one of modern medicine's biggest challenges. Thank you for watching. We truly appreciate you taking the time out of your busy schedule to spend a few moments with us. It's viewers like you who make all of our efforts worthwhile. Your curiosity and enthusiasm for learning are what drives us to continue creating content. We sincerely hope that you found this video enlightening, full of intriguing insights and fascinating facts, providing a window into the wondrous world of science that surrounds us. We would be immensely thrilled if you could show your support for our channel by clicking the like button. It gives us the motivation to continue producing high-quality content. Sharing the video with your friends and family not only helps them quench their thirst for knowledge, but also helps us reach a wider audience, promoting the spread of scientific understanding and appreciation. And of course, subscribing to our channel ensures that you stay connected with us, receive updates about our latest videos, and join a community of like-minded science enthusiasts. It's completely free and takes only a moment, but it means the world to us. By doing so, you would be contributing to our mission of making science accessible and engaging for all. We have so much more in store for you, so many more captivating science stories that we can't wait to share with you. See you in the next video.